Lesson 1-7, Day 2, Functions. Our essential question today is how do you write an equation in function notation? And our vocab word is function notation. We started to talk about this a little bit yesterday, so it should look a little bit familiar to you. Function notation is a specific notation where you identify a letter for your function and a variable that it's written in terms of. So f of x equals 3x minus 5 would be an example of function notation. This letter f right here you read as function. When you say it out loud, you may have heard me say f of x. That means that it's a function in terms of x. Now the letter f is sometimes changed to G or H or another letter like that. And that would just be if you have multiple functions, they don't want to use the same letter. So f of x means that it's a function in terms of x. So that the variable on the other side has to match. So right here, this x in f of x means that you have to see the letter x on the other side. It's a function in terms of that variable. So if that variable was different, it would also change in the parentheses. So for example, if it said f of m, then you would expect to see an m on the other side, like that. So these two variables should match right here and right here. Okay. Now, keeping that in mind, we have 5 examples that you need to write in function notation. They may look a little bit confusing right now because they've got a lot of letters in them, but I want you to keep in mind that the function notation side is the left-hand side, so that's the side that we're going to change. We're going to change, and we are going to change it so that it matches the variable on the right-hand side. It has to match the variable that you see on the right-hand side. So I'm going to use the letter f for all of these. So my first function is written in terms of the letter x, the variable x. So my first function has to look like this. Now my variables match. My variables match. The y that was on the left-hand side got completely replaced. Completely replaced. So instead of y equals, it's a function in terms of x. The next one is not a function in terms of x because it has the letter s. I'm going to name it as a function in terms of s because s is the variable that we would plug something into to solve it. The next one has a letter m. You may notice that the right-hand side of these is not changing at all. The next one is a function in terms of h. And then the last one in terms of r. So the left-hand side changes to function notation, and we match our variable to the right-hand side. That's it. Now, back to plugging in. We did some of this yesterday, but we need some more practice. Because what we find is that if we only do a couple of examples, our students think it's pretty easy. And then once you start working on your homework and you see a lot of different types of problems, every time something changes, we have students ask questions about it. So we need to do more examples. So I'm going to write both of my functions over here. Okay, so the first one, f of negative 1, I'm going to plug in negative 1 for x. Now, using the order of operations, I know, PEMDAS, that exponents come before multiplication. I also know that negative 1 squared means negative 1 times negative 1, which is going to turn it into a positive 1. So, f of negative 1 equals 3. Equals 3. My next one g of 4. I'm going to slide over here. G of 4 equals, so I plug in 4. Now following my order of operations, I would multiply to get 16 and then subtract 5 to get 11. Next, it says f of 2 plus g of 0. F of 2 plus g of 0. Okay? So we've got two functions that we're going to be using here and evaluating. The first one is f at 2, so that would look like this. I plug in the 2 for x in my f of x function, plus I plug in a 0 in my g of x function, so that's going to look like this. So notice, this side over here is my f of x function, but this side over here is from my g of x function. Now I solved the entire thing. So first I would have to do an exponent. So 2 squared is 4. Then I can do my multiplying. So my multiplying would give me 12 plus 0, and then minus 5. 12 plus 0 is 12. 12 minus 5 is 7. So f of 2 plus g of 0 equals 7. So this was my final answer. Last but not least, g, and we've got to plug in 5x plus 1. 5x plus 1. I'm going to see if I can shrink this a little bit to get more space. Whoops, the line came with me. Okay, so we're going to plug in 5x plus 1 in our g of x function. So where the x is, I put in parentheses 5x plus 1, like that. Remember from yesterday's lesson, from day 1, that you're going to have to bound this. So when you are plugging in 5x plus 1, please keep it in parentheses. 4 times 5x is 20x. 4 times 1 is 4. That's distributing. Combine your like terms, and you get 20x minus 1. So that is my value for g of 5x plus 1. Final answer. Now we have a little matching for you. Click and drag. In the classroom, of course, we would have students do this. And if you can solve these in your head, mental math, go for it. So, if I plug in 3, 3 squared is 9 plus 4 is 13. So I click and drag. Plug in 8, 8 plus 2 is 10. Plug in 1, 8 minus 1 is 7. Plug in 5, 5 squared is 25, minus 5 is 20. Plug in negative 4 plus 8 is 4. And just to make sure, I'm going to do this last one, plug in 4, 4 squared is 16. You never want to just click and drag the last one because it helps you figure out if you've made a mistake. Okay, now a review. This is a review from the first day. Can you tell if something's a function, yes or no? Students would come up and click and drag again. They always start with the graphs. This one fails. The vertical line test. My vertical line touched 2 points. That's a failure. This one passes. This one fails. My vertical line again, if I draw one over here. The next graphs they would go to. This one fails. Right there. This one passes. Okay. Then probably move on to the tables. Now, this one has the 6 repeating in the domain. Can't have that. This one has no repeats in our domain. This one has no repeats in our domain. Because a positive 4 and a negative 4 are not the same. Positive 3 and negative 3 are also not the same. This one's got a repeat, so it fails. That repeat is right there. Okay, now the ordered pairs. I see 2 5s in this one, in my x values, or my domain. This one, I don't see any repeats at all for the first numbers. Remember the first number in the ordered pair? That's your domain. No repeats because each arrow comes off of those ones. No repeats. And then these two have a repeat. Right here, there are 2 arrows coming from my 2, 2 arrows coming from my 4. So that would cause a repeat in the domain. If it was written in table form, you'd see that number written twice. If it was graphed, you would see that it would look like similar to this, where there would be 2 points that were on the same vertical line. Time to write your summary. So please go back to your essential question and answer that question. Please write complete sentences and make sure you restate the question so that someone reading your summary would know what the question was that was being asked. So we don't want just the answer, we want you to restate the question first. And here are your homework problems.